Hello everybody, welcome back to another Gregorius Maths video. Today, put on your seatbelts, ladies and gentlemen. This is going to be a journey. OG fans will remember one of my first videos, which was 2 ways to integrate cosine of ln of x. But that was a baby integral, that was really easy. Now we're going to do an integral which has no elementary antiderivative that I know. I'll look it up after the video. But this is... someone in the comments, please tell me how many substitutions I did. Because this is going to be a lot of substitutions. As I've already said, this is going to be a journey and a half. Trust me. Oh, that was quite a nice sound. Oh, okay, I'll do this. Okay, so what we're doing is I equals the integral between 0 and pi over 2 of ln of sine x dx. Okay? So you'll remember I did cosine of ln of x. This turns out to be much more filthy. Okay? I guess the answer is very nice though. Spoiler alert. So, what we do, is substitution number 1. Let pi over 2 minus u equal x, therefore implying that minus du equals dx. Okay? So I is also equal to the integral between. What are our new bounds? Well, when x is 0, u has to be pi over 2. And when x is pi over 2, u must be 0. Okay? So these bounds I find very unsatisfying. Because, you know, they're the wrong way around. Okay, of ln of sine of pi over 2 minus u is cosine of u. That's one of the reasons it's called cosine, because, you know, complementary angles. Times negative du. Okay? But the way to cure your OCD, you know, these bounds are really annoying you. Well, thankfully, we have this negative. So, we can A, get rid of the negative, which is really nice. And B, flip the bounds of the integral. So, 2 birds with the 1 stone, I guess. 0 and pi over 2. Okay, why can we do this? Well, remember that the integral between a and b of f of x dx is equal to negative integral between b and a of f of x dx. Okay? And now, we can add these 2 integrals together. We can put our little addition sign here. Okay? That means that 2i equals, again, the integral between 0 and pi over 2 of ln of sine x plus ln of cosine x dx. But what's ln of x plus ln of y? That's ln of xy. Okay? So we have our ln of sine x cosine x dx. Why is this cosine x and not u? Well, this u, once we've done our substitution and plugged in all of the stuff, is a dummy variable. It doesn't make a difference what it's called. Okay? So we can change it to an x. And now, recall a pretty famous trig identity. The double angle formula for sine. Sine of 2x is 2 sine x cosine x. Okay? So this is equal to the integral between 0 and pi over 2 of ln of sine of 2x over 2 dx. Okay? And now this is good. This is very good. This is equal to... yes. The integral between 0 and pi over 2 of ln of sine of... can't say it. X. Okay, this number here is really annoying us, because if it was just a 1, then it could go away. Then we'd be left with I. 2i equals I plus some number or minus some number, whatever. And it's all great because we can just do simple algebra. But no, it has to be 2x. I'm angry now, in case you didn't notice. Okay, but then remember we have to subtract ln of 2. What's the integral between 0 and pi over 2 of ln of 2? Obviously it's just minus pi over 2 ln of 2. Okay, and now, what can we do? We can do substitution number 2. Let u equal 2x. Therefore du over 2 equals dx. So this equals 1/2, I'm bringing this over 2 to the front, integral between 0, and when x is pi over 2, u is pi, okay, of ln of sine of u du, minus pi over 2 ln of 2, okay? And now, what's great here is that we can perform mathematical surgery, because right now we just want this 2 not to be at the front, but we want it to just slide underneath that upper bound, okay? But unfortunately we can't do that, which is annoying, okay? However, yeah, we can be surgeons, mathematically speaking anyway. I wouldn't trust myself with a spoon operating on anybody, to be honest. However, mathematically speaking, I'd consider myself a decent surgeon. I don't know. This equals 1/2 integral between 0 and pi over 2 of ln of sine of u du. And then we have to add the integral between pi over 2 and pi of ln of sine of u du minus pi over 2 ln of 2. Okay? This is precisely 1/2 I. Okay? And now, substitution number 3, I believe. Let pi over 2 minus v equal u. Therefore, negative dv equals du. So, we add the integral from. Okay, so when u is pi over 2, v is obviously 0. When u is pi, v is negative pi over 2. Okay, hold on. Okay, of ln of sine of this is just cosine of v, negative dv. And now we do the same stuff. Use this negative to flip the bounds of the integral, or as Papa Flammy would say, integral. So they become from negative pi over 2 to 0. And then subtract pi over 2 ln of 2. Now we're getting closer. Okay. Now, I'm warning you, do not let some w equal v minus pi over 2. Otherwise, you'll go round in circles and end up back here, which is really sad. And originally I tried that, and I got really upset. And I kind of rage quit and you know, stormed down the stairs and was all angry. But then I realised that the substitution was so blindingly obvious that it made me blind. Well, not literally. Okay? What you have to do is let some w equal negative v. Yes, it's that simple. Also, I've never used w. I've never gone this deep into the substitution realm. Okay? This journey has taken me deep down into the different variables we can use for substitution. Okay? Anyway, either way, negative dw equals dv. So now this equals 1/2 I plus the integral between 0 and pi over 2 of ln of oh yes! Yes! Okay. Thankfully, oh god, I was a bit worried there. My heart was racing. Thankfully, we can exploit the fact that cosine is an even function. So cosine of negative w is equal to cosine of w. Okay? Alright, that's great. Sorry. Negative dw times. Okay, but this is going from, well, when w is, when v is negative pi over 2, w is positive pi over 2. When v is 0, w is 0. Thankfully, we can do the same thing. Use that negative there to flip the bounds. Between 0 and pi over 2. And don't forget to subtract pi over 2 ln of 2. And now I can smell the scent of an integral being finished. Okay. Here we clean everything up. Oh goodness. I forgot to do something this whole time. I forgot to put parentheses. Oh, brackets. Sorry, not parentheses. No, same thing. I forgot to put brackets. Oh, okay. Forgive me. Oh, I feel so dumb now. Oh. Alright, okay. At least I remember to do it. Better late than never, I guess. Okay. Now remember that this is also I. Remember? That is I. So 1/2 I plus 1/2 I means that this 2i is equal to I minus pi over 2 ln of 2, which means that I equals negative pi over 2 ln of 2. Okay. What a journey. I don't know how many substitutions I made, but I know it was a lot, and I know that this integral took me a freaking hour to do. I killed you. Correct. Goodbye. Freaking.